Video, we are going to see about counters in digital electronics. What is a counter? Counters are used to count the occurrence of event. For example, if you want to count the number of vehicles passing this toll gate, it can be done by a counter. So in other words, we can say that a counter can be used to record how many times some event has occurred. Using counters in real life? Yes, you take the sports. If a person is hitting a goal, the scoreboard will show the number of goals here. When another whole goal is hit by the person, the scoreboard will increase. So this is basically a counter. So what is a counter in digital electronics? We have seen that counters count the occurrence of event. If we use the binary numbers 0 and 1 to count the events. For example, if I want to count the number of cars passing a particular region, I can design a counter such that I display the number of cars with the help of the binary numbers 0 and 1. So what should be inside the counter to do that? It is basically a set of flip-flops and logic gates can be used. We know flip-flops and logic gates work with zeros and ones. So using this thing, we can do counting. So what is a counter? It is basically a set of flip-flops which will change its state based on the number of events occurring. For example, if I give a pulse to the counter, this pulse will be considered as an event and the counter will count. These four things are called the states of the counter, that is 0 0 0 1 1 0 1 1. So this is called the four states of a counter. So basically we can design a counter for any number of states. Here I am showing only four states. So the state of a counter is that so if one event has occurred, it will be in 0 0. When the next event occurs or when the next car enters, the counter will increase to 0 1. When the third car comes, it will move to 1 0. Again, when the fourth car comes, it will go to 1 1. So like this, whenever an event occurs, this counter will change its state from 0 0 to 0 1 or it will go to the next state. How many flip-flops are required to design a counter? So that is a big question now because we have seen that a group of flip-flops can be used as a counter, but how many flip-flops do we need for a particular application? So with one flip-flop, we'll have only two options. Either you will get 0 as output or 1 as output. So with one flip-flop, we are able to get two states, 0 and 1. Okay, so either the counter can be in 0 state or 1 state. So two states are possible with one flip-flop. Suppose if I have two flip-flops. With two flip-flop, you will get four combinations. That is 0, 0, 0, 1, 1, 0, 1, 1. So four combinations are possible. So I can say that with two flip-flop, I can get four states. That is 0, 0, 0, 1, 1, 0, 1, 1. So four states are there for this counter. So it is also called 2-bit counter because two bits are here and it is a 4-state counter because it counts from 0 to 3. Okay, always counter starts from 0. So 0, 1, 2, 3. Again it goes back to 0. So this is also called as 4-state counter. How many flip-flops are required depends upon the number of states required in a counter. For example, if I need two states only, I can go for one flip-flop. But if I need four states, I have to go for two flip-flops. So depending upon the number of state, I have to choose the number of flip-flops. So this is given by a formula 2 power n is equal to n, where small n is the number of flip-flops and capital N is the number of states. So for example, if I have 2 flip-flops. 2 power 2 is 4. So I will get 4 states. 2 power 3 is 8. So I will get 8 states with 3 flip-flop. Sometimes in multiple choice questions, they will ask directly what is the formula for finding the number of flip-flops provided the number of states is given. So in such cases, the formula is n is equal to log to the base 2 of n, where capital N is the number of states. For example, let us take the number of states is given as 8. You can write log to the base 2 of 8, which is nothing but 3. So with 3 flip-flops, you will get 8 states. Next, we will see about modulus counter, or it is written as mod counter. So normally some number will be written here and it is called mod counter. So how many flip-flops are required in mod counter? So we have seen that the formula to find the number of flip-flops is 2 power n equal to n, where capital N is the number of states. Now, you see this table. Here the number of states is given as a multiple of 2. 2, 4, 8, 16. It is like this. So in case I need only 3 states or 5 state or 6 state, some states in between these numbers, what will be the number of flip-flop? That is what I am going to find it out. First, for example, I am taking a 6 state counter. So here it is counting from 0 to 5. So totally 6 states are there. So 6 states comes in between 4 and 8. So what should be the number of flip-flops I have to use? Whether I have to go for a 2 flip-flop or 3 flip-flop. So what happens if I go for a 2 flip-flop? I will get only 4 states. But I need 6 states. So what I have to do? I have to take 3 flip-flops so that I will get 8 states. So in 8 states, I can discard 2 and use only the first 6. So for mod n counter, you have to choose 2 power n greater than the capital N. That is the number of states. Flip-flop number should be greater than the number of states, so that you can design the counter. So with 3 flip-flop, you will get 8 states, but you can discard the 2 states and use only the first 6 states. So in general we can say if your number of states is multiple of 2, that is 2, 4, 8, 16 or something, you can directly use this formula 2 power n equal to n. But in case you have any other number of states other than this value, you can use this formula 2 power n should be greater than n. Next, we will see the types of counter. There are basically 2 types of counter. One is the synchronous counter and asynchronous counter. Synchronous. Already we know this word synchronous means everything is or synchronized together, or they are started together. So synchronous counter in flip-flop, we know there will be a clock pulse. If all the flip-flops are given the same clock pulse, we call it as a synchronous counter. That is, all the flip-flops are synchronized together. Same clock pulse is given for all the flip-flops. Whereas in asynchronous counter, asynchronous means there is no synchronism, that the clock will be different in all the flip-flops. You see this picture, the JK flip-flop, the clock is same in all the 3 cases. All the 3 flip-flops receive the same clock pulse. So it is a synchronous counter. In asynchronous counter, you can see the clock is given only to the first flip-flop. For the second one, the output of the first flip-flop is given as a clock. So when this is given a clock, the same time the second flip-flop will not receive the clock. So this counter is said to be asynchronous counter. That is, they are not clocked at the same instant. In synchronous counter also, there are 3 different types. One is the up counter, down counter and up down counter. So up counter, as the name says, we are doing normal counting or forward counting is done. 0, 1, 2, 3, 4, 5, 6. So it keeps on going in forward direction. Down counter is just opposite of this one. If you are counting in the reverse direction, 4, 3, 2, 1, 0, that is down counter. Up down counter is a single counter will do both the operations depending upon our requirement. If I can use it as up counter or else down counter. Next, we will see the up counter in detail. So up counter counts in forward direction. For example, you can remember this football. So as the number of goals hit by the team increases, the counter will also increase here. The goals value will also change here. So this is forward counting. If I have three flip-flops, so it will count in this manner 0, 1, 2, 3, 4, 5, 6, 7. So it keeps on going in the forward direction. So this is up counter. For down counter, you remember the rocket. So we always, when we launch a rocket, we will always do down counting from 10, 9, 8, 7, 6, 5, 4. That is, you will do backward counting. Or you can also remember the ticket reservations. Okay, initially when all these seats are there, 100 seats are available, it will be showing 100. As the seats are booked, the number will get reduced. You can also tell about the number of items in the stock. While doing online shopping, we know as the stock reduces, the count will reduce. So all these comes under down counting. Next, we have up down counter. So depending upon the requirement, you can use the counter as a up counter or down counter. For example, in a hall or a movie theater, you want to know how many persons are entering and how many persons are leaving the hall. You can use this type of counter, up down counting. For initially, we will use a up counter, then we need to use a down counter. And or you can in industry they may use for how many items are produced in a day and how many are delivered or packed. So all these details can be got using a up down counter. So we have seen different types of flip-flop like SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. So for counters, we can use any of these flip-flop. So normally JK, D and T flip-flop will be widely used. So before going to design a counter, you should be aware of the truth table as well as excitation table of flip-flops, all the flip-flops, so that it will be easy to design a counter. So if you are not thorough with the flip-flops truth table and excitation table, please go through these videos so that you will get the basic understanding of this flip-flop and then you can go and design a counter. It will be very easy. Apart from digital electronics, in this channel we have lecture notes for power electronics, solid state drives, circuit theory and basic electrical engineering. Apart from that, if you need any information, you can mail to readelectricvehicle@gmail.com. Thank you for watching the video and please subscribe to your friends.